session. So we're going to talk about Groovy. If we have the slides, it would be better. Yep, we don't have the slides on the screen. Yeah, thank you. So to complete the description, so who am I? This is Groovy Code for those of you who don't know Groovy. How many of you use Groovy maybe already in the room? Okay, so I assume that most of you are Android developers. So you use Java, most probably. So those of you who are lucky enough to know Groovy, that's cool, because now you will be able to use Groovy to build Android applications. And for those of you who just use Java, I will show you what you can do with Groovy. So I am a Groovy core committer. I work full-time on Groovy since a bit more than 3 years now. And I wrote some features like the new static compiler, traits, we'll talk about that, and Android support. So if you have any questions about Groovy, about the language, don't hesitate to ask me, even in the conference. After the conference, I will be very happy to answer those questions. So the first question actually for Groovy and Android for me was, why choosing Android? So first, it's almost a JVM that you have on Android, okay? So you use Java. Actually, it's not the Java you have on a desktop app or a server application. You have some runtime for running Java applications on Android. So it's almost a JVM. And since Groovy actually is also a JVM language, it was some kind of natural fit. Another reason that was really personal for me to use Android is that the SDK is free. You know, you don't have a barrier to stop coding an application, a mobile application. You have all the tooling available for free, so it's really easy to get into Android development. Once you start developing applications, you can start to feel the pain of writing Android applications, but the entry point is cheap. Last, anybody knows about Swift, I assume. So Swift is a new language made by Apple to develop applications on iOS. And the funny thing is that Swift was announced the same day as we announced that we would support Groovy on Android. So it was a coincidence. But basically, you have with Groovy everything you have in Swift. So if you are an iOS developer and you know Swift, you probably know Groovy without knowing it, because there are very similar concepts. So the next question is actually, why using Groovy? First, as I said, Groovy is a language which is very close to Java. For you, if you know Java and don't know anything about Groovy, well, actually you know Groovy, because the code is almost the same. And what we do in general in Groovy is removing a lot of the boilerplate code that you have in Java. That's the basics. So everything which is annoying, we remove it, and we add nifty features to the language. Second, it runs on the JVM. So, as I said, Android uses some kind of virtual machine, so why not do that? And since we do Groovy for 10 years now, to ease the development, to make it less painful, we wanted Groovy on Android so that Android developers don't have that pain of developing Java applications the old way, you know, because on the server side now we have Java 8, which is much nicer than the previous versions, but we're not there yet on Android, far from being there. So Groovy will bring some features on that side. This one is actually quite nice. Actually, if you know about Groovy, you know that it's a language which has a lot of different phases. We can do object-oriented programming, we can do functional programming. It's a dynamic language, it's also a static language. it has many concepts coming with the language. But even if we have all those concepts, it's very straightforward to learn it if you come from a Java background. So most of you are probably developers, so you like to see some code. So this is typical code that you would have in an Android applications. And I tend to say that actually Android development in Java is the anonymous inner class paradise. You have anonymous inner classes everywhere. You have to write a lot of code just for a single click. So what happens here and what matters is only this. You want to start an activity when you click on a button. That's all that matters, right? But the code is really hidden. So in Groovy, we simplify this. You can just say button dot onClickListener equals and the code. Not more than that. You just focus on what you want to write, nothing more. The decoration, all the garbage code, the compiler takes that for you. You don't have to explain that it's an anonymous inner class. The compiler knows it. So Groovy will simplify how you read the code. This is another example of Groovy code that you will find in mostly any Groovy application. First, you have those fields. If you come from the Java background, you may see that actually there's no modifier here. There's no private field, no public field, just no modifier. Actually in Groovy, what this means is that you have a private field and the getter and the setter generated for you. So you have properties, right? So this is what you do most of the time, actually, in an application. You create some bins, and then you have properties and getters and setters. So much concise. This is code from a prototype application built from someone in the community, and saying that actually you can define some constraints on your different properties, like saying, for example, that the name must match this pattern. And if it does not, then you have a runtime, an exception thrown, for example, that you can catch, etc. So Groovy lets you build that kind of model on your beans. Then you also have that, which is, for example, the toString application. We call that an hasty transformation. It's a big word just to say code generation, right? But toString just means, okay, in general, it's quite nice when you debug something to have a nice toString version of a code. So why should I care about writing that? I mean, the compiler is smart enough to generate a toString for me, so just annotate with toString. And we have lots of those annotations that you can put on your code. Okay. This is a new concept actually in Groovy that came in Groovy 2.3, and it's a concept of traits. And this example comes from a sample application that I wrote for Android. And if you develop an application for the Wear device and the desktop application, you have some protocol to initialize, which is the Google API client, right? And actually, the way that you create this protocol level is the same for the watch, the same for the desktop, the mobile application. It's really, really something that you can share. You create it exactly the same way. So we can create actually a trait, whatever this means, with the code inside that says how you initialize the Google API client. Then you have some methods. Okay. And when you want some activity, or in this case, any class extending context, to be able to have that protocol initialization layer inside, you just have to do that. You just create your service or your activity and implement that trait. And then you can call those methods directly. So you have sharing of components done directly in the language. You can just create those traits with all those features that you know you're going to share in different activities, different services, etc., and have that directly embedded into your class. So you don't have to deal with delegation models or just multiple inheritance problems. You don't have that problem in Groovy. You can just do that. This example is also from the sample application that I wrote. And if you have to remember one thing about Groovy and Android for this talk, it's this slide and the next one, because I think it's the most important. So we take some time to explain. Why you should use Groovy is exactly that. If you take a look at that code, you see a lot of things that you don't care about. You really don't care about all those stuff. It is just, in the end, sending a notification. So just to build a notification, which is sent to the device, I have to write all that code. And if you take a look at that code, you have new intent taking this as a parameter. In Java in general, when I see some code using this as a parameter, I know there's something wrong. There's a design problem somewhere. Passing this as a parameter is always strange. Whatever, we need that. But actually it's worse than that. We have static methods using this as a parameter. Oh dear. Okay, static methods. And then you can see that I have notification compat. Whoa. So you're Android developers, I'm a Groovy developer, and that shocked me because I'm not used to develop Android applications, and I started to write applications to make sure that Groovy could run on those devices, and I wanted to feel the pain that you have writing those applications. And I felt it. Because you read the documentation and it says, okay, to build some notification, you have to use the notification API. But it's not very clear that actually you don't have to use the notification API, you have to use the compatibility version of the API. Because otherwise you cannot run on all the devices. So everywhere, actually in the Android code, you have those compatibility APIs that you have to use. Really, you have to. Because otherwise your application will not run on all the devices, lower level APIs. So the way the Android APIs are designed are for backwards compatibility. So it is just complex to use just for that reason, because otherwise it would be complex to maintain backwards compatibility. So it's much easier to create classes that take this as a parameter, just not to break binary compatibility, for example, because it's another class that provides the feature. So you have static methods in compatibility classes, and you can call them. And then you grab objects from those support classes. But in the end, that's really not what you want to do. You want just to send a notification, nothing more than that. Okay, so I got fed up with that code, and I wrote that instead in Groovy. It does exactly the same. Really, it's the same thing, but you can see that already I have a single notify method. So all that block of code that I have here, notify is there. It's in the end, and it's hard when you read that code to know that actually what the block is doing is just sending a notification. Here, I have a notify block. So I know that everything inside is for the notification. It's scoped. You have a scope. Then you can see that actually we have some syntactic sugar to remove, for example, the setters, etc. And we have string interpolation, etc. And you can call pending activity intent just to create, and I don't have a single this inside that code. And more than that, I have hidden all the fact that I'm using the compatibility API. And that is important because Groovy would let you write that kind of code very easily, actually. So imagine that you started using the normal API and that you want to go to the compatibility API. You don't have to change the business code. All you have to change is the code that makes this possible. And just to show you how simple actually it is in Groovy to write this, it looks like that. You create a class and you have some static methods to define, but actually the first parameter of the method is the class you want to decorate, right? So when I am writing a static method that takes a context as the first parameter, actually what I am doing is adding a new method on the context class. So any class that will extend context will have that method available directly on the message. So in that case, I could write, for example, get compat notification manager on context, and actually it will generate, well, that's not, yeah, it's not a problem. Don't worry about that. But notification or notify is actually something that will take a closure, and the closure is the block of code, etc. So don't worry if you don't understand precisely what this does, but what you have to remember is that Groovy makes it very easy to write that kind of APIs and hide all the complexity. In the Java code, actually, I had something using, so it takes some time to find it, but there's an icon used. And here I have a decode resource that uses, it uses, it's hard to read, okay. But actually in my Groovy code, I am just using the icon as a cached bitmap property. And this is smarter actually in my code because I can write this private lazy bitmap. So what this will generate for you is actually caching everything for you. The bitmap will only be loaded if your code is called. Whereas in the Java version, it was generated every time. Okay? So it will load the roses every time. Here it is cached and loaded lazily. So in general, you don't do that in Java or very late just because you have performance issues and it's very hard to write, actually. Caching, etc. It's hard. Just add an annotation, then caching and lazy loading, and it's done. Very easy to do. So the next slide is actually the application that I run on my watch, which is written in Groovy. And since I'm doing some conferences, you still have, some time to talk, etc. And the idea was that my watch would vibrate every 10 minutes, say, to tell me, okay, you need to hurry. So it's a demo application written in Groovy that works on both the phone and the watch. And you have all the code available on GitHub. So feel free to take a look. And yes, I am not an Android specialist, so if you find some horrible code, you can create a pull request, and I will be very happy with that to learn the best practices. Okay, so this was just to give you an idea what you can do with Groovy. But actually running Groovy on Android, why didn't we do that sooner? And there were multiple problems actually for Groovy. The first one is that historically, Groovy is a dynamic language, just like Ruby, just like JavaScript. It's a dynamic language. And if you start using a dynamic language inside a device like that, even if it's powerful, the application is going to be very slow. And probably will drain the battery. Because it makes use of reflection. Everything happens at runtime, basically. So when you invoke a method, you have to determine which method is going to be called at runtime. So there's a lot of things happening at runtime. And actually in Groovy, We made a lot of work to make this fast on the traditional desktop applications, but all those techniques that we call side caching, etc., are not available on a mobile device, so we don't have those optimizations. So it was very difficult to do. So that was a problem. And the last is probably the worst problem. Actually, Groovy generates classes at runtime, especially if you use the dynamic mode. So imagine a device compiling code and loading that at runtime. Well, okay. Other problems were that even if it's some kind of JVM, you don't have some packages that we use in Groovy. So the JavaBean thing is a problem, but you also have not JVM but runtimes, so the Dalvik runtime, the Art runtime, etc. So we had to make some changes in the Groovy distribution to make it available. Just talk about Dalvik and Art. Actually, it's a runtime, so it means that the bytecode that you generate when you compile a class in Java or in Groovy actually is not the one which is run on the device. You have a tool chain that transforms everything into a bytecode that the Dalvik runtime understands. And it's different. Groovy generates some JVM bytecode, not the Dalvik bytecode or the Art bytecode. So we had a problem. And actually, it's the tool chain in Groovy, in traditional Android application that converts that, and it's done at build time. Well, for Art, it's a bit different. It's done at 2 different times, but don't worry about that. And the last one is probably the most exciting, is that even if you take a look at the API in Android and you find a DEX class loader, you will find that actually it's not capable of loading DEX classes. So it's very strange, but to be able to load DEX files, you have to put them into a file, have that file into a jar, and then you're able to load that. So it has to be on the physical file on the device. So we know that it's complex to do that, but you can imagine that it's very slow because you have to write that on the device. So let's take a look at what a classic application design is and how you compile application in Android. So you just have an insight of my incredible design capabilities. So this is the most exciting diagram that I am capable of designing. I'm very happy. So when you compile an Android application, you start from Java files. You compile a source and you have class files. Okay, but then you have the DEX tool, okay, which will convert the bytecode from the JVM bytecode to the one that actually Android understands. And it generates a classes.dex, and then you can have an APK, etc. And you deploy, and everything happens at runtime. So there's not much happening here, except for Art, where there is an additional actually phase here that converts the bytecode to something optimized when you install the application. So the first time you install an application, there's an optimization phase. What we want to do with Groovy is actually the same. We want some Groovy files, compile them, then have the class files, dex them, etc. So it shouldn't be that hard, actually. And it's not. But in Groovy, you can do more than that. Actually, you can have also the same happening at runtime. Okay? It is possible. And this is actually a prototype that some guys wrote back, I think it was in 2011, and they wrote a prototype and they wanted the full Groovy test suite to run on an Android device. Yeah, why not? But actually it works, but it is very, very slow. And there's a lot actually of I/O involved, because as I said, each time you generate a class, you have to write it on a file system and load it. So compilation, loading, converting, all things that you use on a laptop, on a server, whatever, that you do at compile time, imagine that done on the device. So it works, but it's awfully slow. There is also a tool that we use to generate the bytecode actually in Groovy called ASM, and there is a version dedicated to Android DeX format. The problem is that we couldn't use that because it's a totally different API, so it was too much work for us to do that. So basically this approach of generating all the classes at runtime, etc., is the one that the Ruboto team took, and Ruboto is the Ruby version of the Android version of Ruby. So that was not what we wanted to do actually. So we redefined the objective for Groovy in Groovy 2.4. So Groovy 2.4 is the first official version of Groovy that has support for building Android applications. So released that last week or the week before, I don't remember exactly. I think it's, yeah, last week. So you have full support for building Android applications in Groovy only in 2.4, right? But what is really important is that we wanted to focus on statically compiled applications. So forget about the dynamic aspects of Groovy. Groovy was primarily a dynamic language. Since Groovy 2, we added static compilations so that it behaves like Java and everything happens at compile time. The version of Groovy for Android is built on top of that. We focus on static compilation just because you don't want to drain your battery doing stuff that you don't care about, right? It's very important in mobile development. And in the end, you will see that there's no performance issue doing that. You know, you will generate bytecode that runs at the same speed as Java files. So that was the objectives for us as the Groovy team. But actually, the language is one thing, libraries is another, and actually we think in the Groovy team that the most important is the community, so you as users. So we define objective for the communities too. Actually, we can design the best language ever. If you guys don't build libraries that use Groovy on Android, well, it's useless. So we want you to take Groovy with you and start using the kind of things that I have shown with the intent DSL. Just to bring some grooviness to Android development. So it's your turn to do that, invent new frameworks. So you may wonder actually if we have something in production working. And yes, we have, because that application was written almost 1 year ago actually, when we announced that we would have Android support. So it's already on Play, Google Play, it works. And it was an application for GreatConf, which is the Groovy conference that we have in Copenhagen. And the idea was to demonstrate that it was possible to develop a Groovy application using the agenda. So you can do that. And this is just an illustration of what I mentioned about executing code at runtime. So it is possible, and there is a prototype application running, and this application compiles the script that you can see here on the device and runs it. So it is possible to do that. But you see that even on a powerful device, it takes a lot of time to do it. Execution is pretty fast, but compiling the script, yeah, why would you want to do that? So it is nice, it is fun to take a look at this example, but don't do this. You know, don't do this at home. Experts. So why do you need actually to be able to build an application in Groovy? So first of all, the focus is the new toolchain. So we're based on the Gradle build system. And it's interesting for us too, because you know that Gradle uses Groovy internally, so you will have the full chain built with Groovy, so the build tool, your application, tests, etc., all written in Groovy. It's quite fun. But important is that actually you don't have to use the normal version of Groovy, you will use a specific version of Groovy. And last is, especially for me, find some good tutorials about Android just to stop scratching your head and asking why it doesn't work. Okay, so first, make sure that you use the Groovy classifier of the Groovy version. So it's not the usual Groovy jar that you're going to use, it's the Groovy version. Just because of those things I explained before, missing classes, etc., this jar just brings more than what the normal jar provides. So it's interesting just to know that, because otherwise you will start your application which will fail. Then you have a Gradle plugin. You just apply the plugin, which is groovyx.groovy Android. And that's all, basically. So it looks like that. You take your build script, you add a dependency on the class path on the plugin for Groovy. You define that you apply the plugin and the dependency with Groovy. And the plugin takes care of everything. So you can use it with the application plugin, the library plugin. We have a single plugin taking care of all the variants, etc. So it's really easy. And then, yeah, you can code. You can use that kind of stuff in your application. So a class with beans, with the properties and equals and hash code generated for me, because I like that. I don't want to write code that the compiler can write for me, basically. That's the idea behind Groovy. I want the compiler to be smarter than me. Often it is. Too often. Last, we want to provide new APIs, but that's not our focus as developers. But basically, async task. Well, when I saw that, I was, can it be that complex to run something in the background? Seriously? Yes, it has to be that complex. So there are some libraries that make it almost transparent. It's not the point, but in Groovy you can write that kind of code, for example. Just saying, okay, I'm replacing all that stuff and saying, I'm going to just pass some JSON feed, which is whatever it is. It returns a JSON structure, and then I know that the JSON has a field named speakers, and I can join it. And then when this is done asynchronously, sorry for my accent, then update the text view and done. I mean, it's more readable. You don't have to care about how it's done. What you care is what you want to do. So pass a JSON field and update some field in the UI, nothing more. So let's talk about performance, actually, because some people will tell you that Groovy is slow. Ooh. So first, I took the example of the GradeConf agent application that I saw the screenshot before, but basically the idea is that the Groovy jar is 4.5 megabytes. Well, but actually if you compile it, convert it using DEX, it's much smaller, it's only 2 megabytes. And if you take a little more efforts, you can go down to just 1 megabyte. Right, just because with the ProGuard you can reduce the number of classes used, etc., etc. So you can really have something small. I mean, 1 megabyte is not much when you know that just to download cat videos on YouTube, you know how much. Well, but for an application. And last, actually, we use only 8 megabytes of RAM. And when I took a look at the memory snapshots, sorry, I saw that most of those were actually pictures, images. So there's no overhead basically on using Groovy if you use compile static. Compile static to enable static compilation. If you forget that, it will be slower and it will use more RAM, but it's easy to fix. So community. I really want to insist on that part. Community is very important, very important. I started using Groovy as a developer, like you. I used it in my company, previous company, and then I started contributing to Groovy because I wanted more features, I wanted to fix some bugs, I wanted to improve the performance, etc., etc. So this is really important for us to have people contributing to Groovy, and not specifically to the Groovy language itself, but also just writing stuff in Groovy. So we need new frameworks, but actually some people already started doing that. So even if the official Groovy version that supports Android is only 1 week, released 1 week ago, some guys already started writing frameworks for that. So Swiss knife, maybe some of you know butter knife and Android annotations. So the idea is the same. You can have annotations that you put on your code just to simplify view injection, threading model, etc. So annotations that you put on the code, but the difference with butter knife and Android annotations is that this happens at compile time in the Groovy compiler itself. So there are no proxies generated, no additional classes generated. It's just your class which is modified. So there is absolutely no overhead on using this. It's just code generated for you, just like the toString annotation that I showed before. So what does it look like? Oops. You can actually define a field, a text field, and then annotate it with the view by ID and set the ID. And then the code that will inject this view into your activity is written for you. So you don't have to care about casting, find view by ID, etc., etc. You know all the code that when you start developing Android application, you say, how is it possible that I have to write so much code? Just, I want a view. I mean, it shouldn't be that complex. So just annotate and done. Same for events. Instead of adding new events with anonymous in the classes, etc., annotate the class with onClick and you're done. This is another way to handle the async task that I have shown before. So in Swiss knife, it's just annotating a class with onBackground, and it will take care of generating all the code that is required to do the task in the background for you. Pretty easy. You have things like that. For example, you still have to save the state every time in Android. It's quite painful because you have to write the code for it to work, but actually you don't care about that. You just want to say that this must be persisted. You don't care how it should be persisted and when it should be done. So you just annotate with save instance and done, right? One last example in Swiss knife is the parcelable stuff that you have. So it's the serialization mechanism that you have for networking, basically. And if you do that in Java, you have to write a lot of code because you have to create your class, define the fields, define a constructor accepting a parcel, plus all the methods that will do the serialization stuff. I'm not mentioning the getters and setters if you want to have some. Lots of code, okay? In Swiss knife, you just simplify that to this parcelable class. Done. 3 lines of code, okay? No, 4. Just I could have done it in 1 line. So that was really a project that that is really important now. But we have others. For example, we have Groovy, and Groovy is just a prototype to generate views, because sometimes you don't want to rely on the XML files, you want to generate the view programmatically. And the goal of Groovy tools is actually to make it groovy. That's the word, because we use the builder syntax, so you can have a relative layout, and inside define that actually you have in-text view, etc., etc. Okay. So if you want to contribute, don't hesitate. Those are all open source projects. Okay, so I was very positive so far about using Groovy, but I need to be honest with you. So what are the potential issues that you will face if you develop Groovy applications for Android? So the first one is performance, because as I said, if you forget to statically compile your code, it might run fine on devices like this one, but on lower-end devices, it's going to be slow, so you have to be careful and just annotate your code with compile static whenever possible. In some cases, it makes sense to use dynamic features of the language, like in the JSON example that I showed before. It's totally dynamic code, but it's very limited. It's not in a loop on the UI, for example, so if you run it once every 10 minutes, it's really not a problem. That's dynamic code. The problem is that if you really start using it as the main application loop. The second one is not my fault. It's the number of methods that you can have in an APK. I mean, I was very surprised when I learned about that. Say, whoa, especially if you use the Google Play services, you know, so you have 4K methods left for you for your application. So use ProGuard, and now it's much easier now because there is a new plugin for Gradle that makes it very easier to use the multi-deck support, and you have basically nothing to do, so it's not much a problem anymore. I would say that the main problem that you may face with Groovy is not the language, it's more the tooling support. So I am working with Android Studio, and those of you who use to know that you have an update every 2 days, and often that when you update it breaks your project, right? So it will happen too with Groovy. And there's nothing I can do for that. So just a little quote from a previous conference where Ken Kausen was giving a talk about the Gradle support, actually, of Android builds. He was saying, okay, I would just update my Android Studio just before my talk, and obviously nothing bad will happen. So it was pretty funny. So we have more ideas. Probably some of you already use Dagger, for example, for dependency injection. If you use Groovy, it's Groovy code, so Dagger doesn't work out of the box because it's not capable of handling Groovy files. But the good news is that Dagger 2 will. Currently, we only have one problem, which is the Gradle bug, so it's going to be fixed soon, so you will be able to use Dagger. And yes, for example, data binding APIs, I mean, it's so horrible to have to pass everything and all those events to say, I need to update there and synchronize everything. We have lots of things to invent. So to conclude, I just want to say that don't be afraid of using Groovy, because some already do, and actually the New York Times is building its new application fully in Groovy. So yeah, you can use it in production. And I think we have 1 minute or two for questions. So
thank you very much. The first question is, we've seen the emerging new type of languages. It's high-level languages like Swift, like Groovy. Is this the way how it will be in the future?
Yeah, probably. Groovy, Swift, even Scala, Clojure, I wouldn't say that it's a modern language because it's Lisp-based, but all those languages try to improve everything that, you know, you don't want to write as a developer. So yes, it's going to be the future, and especially Java 8 goes into that direction with lambdas.
So a little bit making the programming for the people, not for the closed group.
Not for?
For the closed group. So
yeah.
Yeah. Okay. So we have a time for
it's
two
still
more
programming.
questions. Yeah. So we have a time for 2 more questions.
Is there any problem with debugging?
With debugging, good question. So there was a problem recently, but I think they fixed it in the last version of Android Studio. But basically, it's a problem of must adding some watch in the IDE. So sometimes you have some problems, but in general, it works pretty fine. Yeah.
Okay. And the last question, like the previous one. Oh, there's one.
What is the difference in compilation time between Android project written in Groovy and written in Java?
I wouldn't say that it's noticeable. The Groovy compiler is pretty fast, so it's slower. It's a bit slower, but I don't think that you would notice the difference.
Okay. Thank you very much. Just to make sure, there's a device when you can vote for the talk, and the next thing is please take a sip of the coffee next to the talk stand. They have a great coffee here, and I see you around on the next talk. Thank you.
Thank you.